In my last video, when I spoke about the moon rotating around the Earth in such a way that we can only ever see one side of it, and that being convenient, I did some research since then. Well, the process of this happening is called tidal locking. Now, tidal locking is to do with the pull of the two objects on each other. I'm pretty sure due to the way that the fluids and the gases work, the gravitational pull changes. I don't even fucking know what I'm talking about. Basically, there's tidal locking. That's the process of why the moon is the way it is in relation to the Earth. But tidal locking also occurs on Saturn. Which is interesting because Saturn is different to the Earth due to the fact that it doesn't have any water. Okay. So, why this is interesting is because Saturn also experiences tidal locking on its moons, right? One of these moons, I think it's called Mimas. That's definitely wrong, but anyway, something like that. This moon is tidal locked to Saturn, even though Saturn has no water, so you would say it's the gases of Saturn that causes tidal locking, right? The interesting thing about the relationship between Mimas and Saturn is that their proportions, right? So this is Saturn, big Saturn, small Mimas, right? These proportions are similar, if not greater, than the scale between the Sun and Earth. Now you think, why is this important? Well, the Sun is similar to Saturn in that its atmosphere is made up of gases, right? So you would expect tidal locking to also occur between the Sun and the Earth, given they're the same size or similar sizes to Saturn and its small moon Mimas. That's important because, apparently mass has a big play in the process of tidal locking. Now, is that the case? No. The Earth is not tidal locked to the Sun, and when you research this, Google will tell you that it can be expected to happen, but it hasn't happened yet. The process would take 10 billion years or so for this Earth to tidal lock itself to the Sun due to its proportions and whatnot, because the Earth is so small compared to the Sun that it would take that long. It says if the orbiting body has a larger mass, the tidal locking occurs quicker, which, fair enough with the moon, because the moon and the Earth are similar, or at least the Earth is much bigger in the scale. The Earth and the moon, the moon is much bigger in the scale of Earth than the Earth is in the scale of the Sun. Anyway, it says that this process would take 10 billion years or so for the Earth to tidal lock to the Sun due to their size. But Mimas, the moon of Saturn, is already tidal locked to Saturn, and the Earth and the universe is only 4-5 billion years old almost. So it's just a bit convenient that this moon and Saturn, which are similar proportions to the Earth and the Sun, the moon's tidal locked, but the Sun's not. I mean, the Earth is not. It's yeah, I don't know. I don't even know why I'm talking about this. But yeah, there you go. It's just a bit, it doesn't really add up, and it could lead one to think, well, hang on a minute. Maybe they're just making it up. I don't know. It's just, yeah, you wouldn't expect the Saturn to have a tidal lock on this small moon when the Sun doesn't have a tidal lock on the Earth. Even though they're similar size, they've had the same amount of time. One could even say, you could expect the Earth to have had more time than the moon of Saturn to tidally lock, and yet it hasn't. 10 billion years they're going to say it's going to take, which means it's essentially not going to happen. I don't know.